differentiate the given function. So on this function we have given the product of three function, right? So how the three functions are given? We have the theta here, and then multiply that by the cosine theta, right? And then multiply with that product with the sine theta, right? So that type of function we have, and our goal is to find the derivative of that with respect to theta. So how can we find this one? So how can we differentiate f, or how can we find the derivative of this f with respect to theta? So definitely you might have assumed that, or think you have thought that what do we need to do when we have the product rule? Then we need to use the when we have the product of the function, then we need to use the product rule, right? So we need to use the product rule because we have the product of the functions. But the product rule, if you look into it, by the formula, it's just we have discussed how to use the product rule to find the derivative of the product of two functions. So we have product of three function, but does that matter? Because product of the two function is already a function. So if we do the product of some more function with that, then definitely, I think it's reasonable that the formula that we have learned for the product to find the derivative of the product of the two function, we can just extend that, right? So let's use a similar type of concept over here. But to do that, what was the product rule? How did we apply that? Do you remember? What did we do is, if we have a product of two functions, let's say f and g, then we can leave one of the function as it is, right? Multiply by the derivative of the another, plus find the derivative of the one of the function which we have not differentiated earlier, multiply by the another function. So it looks like each time we are just finding the derivative of one function and leaving the another function as it is and just adding them. Since we had two functions, here we have two terms, right? So if that is the case, we can generalize that idea, right? If we have the product of three functions, so that means if we have, let's say, function f, g and h, to find the derivative of these, seems like it's reasonable. We'll find the derivative of one of the function, let's say f prime, leave the product of the another two function as it is, plus write down the first function as it is because we already differentiated that, right? And just let me do the differentiation of the second function, let's say g, and then times, let's write down the h as it is. So in this case we are writing down the product of f and h as it is, plus, and then what we can just do is write down the f and g as it is, multiply by the derivative of h. So each time we are just differentiating one of the function, right? So let's use that strategy here. Okay, so let's find the derivative of the given function then. So let's find then the derivative of the first function. Here we have given that as a theta, right? So let's differentiate that. Okay, and whatever comes up, we multiply by that with cosine theta times sine theta. Okay, plus, now we leave theta as it is. That's the first function, we leave as it is, right? Multiply by the derivative of the cosine theta. We just find the derivative of the second function, let's say, times, leave the, and then multiply by the what was that, the sine theta as it is. So on this term we are just differentiating cosine theta. Okay, and so what is the extra thing then we need to do? It seems like we just need to now leave the first two function as it is, which is theta times cosine theta, right? We leave that as it is, multiply by the derivative of the sine theta, the derivative of the sine theta. So that's what we need to do it, right? So this is cosine theta, this is sine theta. So you might have noticed each time over here we are just differentiating the theta, we are here differentiating the cosine theta, we are just differentiating the sine theta on the last term, because we have three functions here whose product was the given function. So each time we are differentiating one of the function, right? Okay, this is done. That's the product rule. But when I say it's done, we use the product rule properly. Now still we have to differentiate those in the theta. We said we'll differentiate, but we have not done that, right? So let's do that, then we are done. So what is the derivative of the theta? 1, right? So theta with respect to theta will be 1. Okay, so 1 times cosine theta times sine theta, that is the first term, plus theta as it is. What is the derivative of the cosine theta? It is negative sine theta, right? So let's write that down, and then times the sine theta as it is, so we need to write that down. Okay, and then plus theta times cosine theta as it is, multiply by the derivative of the sine theta. That's what we need to do. What is the derivative of the sine theta? Cosine theta, right? So leave that as it is. Done. This is the derivative. We like to write down on some other alternative. It's possible. So let's multiply. 1 times cosine theta times cosine theta will be just cosine theta times sine theta. And the second term over here, when you simplify, I see a sine theta will be sine square theta. There is negative and theta. So if that is the case, this will be actually can be written as what was that one? Negative theta times sine square theta, right? That would be the combination, right? Sine theta times sine theta, we can combine that as sine square theta. In the same way, here we have cosine theta times cosine theta, we can combine them as cosine square theta, and then done. This is another alternative, right? So if you like it, you can write down, or I mean, you can still, if you want to write down some other alternative, this is cosine theta times sine theta. You could take theta out here. When you do that, this will be sine square theta minus cosine square theta. I have written somewhere parentheses for the theta, somewhere not. If you want to write down there, it's fine. Otherwise, it's not necessary. You know that the common practice, we can also write down like sine theta in this way to represent the sine function, or we could also write down sine of theta, right? So whichever you prefer, you can write that down, but you just need to understand that's the sine function. It's not sine something, some function times theta. It's not true, right? So sine theta together will be the representation of the sine function, sine theta or sine x, right? So that's how we can write down. So you just need to understand that. But our main problem was to differentiate this function, and we have done that. Right over here we already differentiate. I try to combine them and then write down as this alternative form, or you could also write down into that, or you can change sine into cosine or cosine into sine by using trig identities if that's what you need it, right? So a couple of other alternatives you can write down, but this is already a good enough good alternative to find to represent the derivative of the functions. Sorry. Okay, all right.